Hi everyone, welcome to this week's live stream. Hopefully everyone can hear me okay. This week we are making a game. So if you haven't joined us before, this game we're making is Zombies Ate My Neighbours, which is a remake of it anyway. And it was a top-down game, shooter arcade game that came out back in the 90s for the SNES and the Genesis Mega Drive. And we attempted to make a 3D Unreal Engine 4 version of it. So hopefully everyone can hear me okay. I've got chat windows open up. I've been having some technical difficulties getting it all set up, so hopefully everything is a-okay and working. I think it's a bit more delayed than I'd like to, but never mind. That's as good as we're going to get it, I think. So hopefully everyone can hear me okay. And yeah, so the aim of today is, well, what we got done last time. So last time we got a basic functionality of having our neighbours represented by these grey mannequins that we can run into and collect, and it'll spawn the end of level door. Now, since last week, the last time we've done this, I've modelled a exit door using Maya. So I'm just going to show you my modelling. So here is the door frame. Let's just give it a basic thing. Let's go basic wall. There we go. That would do just fine. And basic wall just fine there. Okay, so here is our exit door frame. Very simple. Notice how I've slanted it a little bit. That's because I was aware of the orthographic, the top-down view of the game. So I wanted to make sure that it was tilted a little bit so I could see it nice and clearly when the camera's above it. So that's a top tip if you're doing isometric type games. Tilt your world a bit. Let's do our door here. So our door here, gone for sort of a jaunty, janky, cartoony look as well, with its angled edges that aren't too simple. And I put those together into an actor in preparation for tonight. In the viewport here, like so. So all I've got here is my box mesh, which box collider, which we had before, and they're two static meshes on top of each other, like so. So you can see them working. So the aim of today is to get the effect from the game used for the exit door. Okay, that's our main focus. If you don't know what this effect is, it is this thing. So when the door opens, you see it sort of fade in and teleport in and out. So we're going to try and replicate that using Unreal's material editor. So we're going to do it all in materials. We're not going to do anything with particle wires or anything like that. We shouldn't need to. We should be able to do it all in material editor. And so by the end of today, or tonight rather, we'll have that effect done. So if you wanted to learn how to do things like this, or dissolving or make things materialize, this sort of tutorial that we're going to do live will apply for anything that you want to as well. So take what you learn from this and apply it to whatever you need to as well. And hopefully you'll figure out how to make it for your particular project in mind. So what we're going to be doing is, first of all, starting off with the material that we need to make, and talking through how this is achieved. So this whole thing is achieved. Sorry, let me just get my chat windows open. This whole thing is achieved by. Is the video working for you, YouTube? I think it is. I think it's just being a bit lagged. That's right. I don't need it. So this whole thing is achieved by using the material editor, and what we're doing is actually masking out part of the mesh, or part of the material at least, out of the renderer, so that we can't see some of it, and we animate the amount that we are seeing so that it looks as though it is fading in and out. So I'm going to close that, and what we're going to do in here is we're going to create a new material. So all of this is handled by this material, so I'm going to call this my exit door _mat, and I'm going to open this up. So because we are dealing with opacity, because we make something disappear and reappear, we can't just use the opaque material editor. So by default it gives you the opaque one. We need the opacity, or opacity mask rather, for this to work. So for the opacity mask to work, we need to make it so it's unmasked, or if we're using the opacity, to use translucent. I'm going to use masked, okay? But what we're doing here can apply to the opacity as well if you're doing some more gradiated stuff. But we're doing a sort of cartoony effect, so I'm making it blocked colours. So the power behind all this comes from one single node, and that's called a box mask 2D. This function will mask out a section of a material based on a coordinate based system. So a lot of big words and a lot of confusing stuff there, but once I start plugging in stuff, you should see how it works. So let's just start by getting this to work so you can see how it works. So if I plug in my result here to the opacity mask, like so, we need an A vector, a B vector, bounds, and edge fall off. Edge fall off we don't really need to worry about. That's only if you want to do things with the opacity. So if you're dealing with opacity, not opacity mask, you want to use edge fall off. But we're doing bounds here. So I'm going to start with my bounds here, and we're going to make a 3 vector. So the shortcut for doing this is holding down the 3 key and left clicking, and it'll generate a 3 vector. And that will plug into my bounds. Now we need a 3 vector because we're dealing with coordinates x, y, and z. And in the material editor, whenever we're doing stuff like that, RGB refers to x, y, and z. So R for x, G for y, and B for z. So in my R, I'm going to do 50, and my green, I'm going to do 50 as well. And that will go into my bounds of the size, basically, of our box mask 2D. So this is going to, by default, generate on top of the sphere, like so. So very simply, just by putting in bounds, you can see here how this is going to work. Okay. Now you see in bounds here it says V2. That means it's a vector 2, so it needs a 2 vector. So if you put in a 3 vector like this, it's only going to take the first 2 values. Okay. If you want to do a 2 vector, you can do just by pushing 2 and doing exactly the same thing. We can use either. So just to show you that, I can use either. I go 50, 50, and I can plug that into bounds there as well, and you get the same effect. It will just still work. Okay. So let's just delete that on there. So the first thing we've got here is A and B. So these refer to where it's put in this mask. The A is the position of where to start measuring the box. Okay, so by default, as it says there, is the world position of where it is in the world. Okay, so we'll need to tweak that a little bit later on to get the exact effect we need, but for now we can leave it as is. And for B, it's the center position of where the box actually is, so where this box mask actually is going to start. So this box mask we're going to put into a oh, hang on. So I'm just making sure the video's working. Can you all see the video? I can't. My thing's being weird. Yes, you can. Brilliant. Okay. So we got the B value. So it's going to be a position, and I'm just going to use the actor position world space, and that's going to basically tell it to draw this box wherever the actor is that its material is applied to. So that way it will always draw it on top of the actor. So if I click apply on this and close that, I can actually put this on these meshes here. So go exit doormat, exit doormat, and you can already see what it's doing. Okay, so that box that's on top of that sphere, it sort of projects it down. So anything below in that box there will be rendered. Okay. Now you're not getting the sides. That's because it's not a 3D mask. It's just a 2D mask. So you're not going to get the sides unless there's a polygon there, which in this case there isn't. So it's going to just draw out these side bits here. And if I change that vector, that 50-50 vector, that obviously changes the size of this box. Okay. So let me just put that on that door as well. There we go. So right, so we got that part done. Let's give it a basic color. Let's give it a simple wooded color. Let's give it 3 vector into base color, and I'm going to give it a woody sort of texture. Not texture, color. I will texture it properly in time, but for now, let's just get away from being black because black's boring. Okay. So there is our box. So let's work about how we animate it. So in my exit door template here, I want to animate it as soon as it's created. So on begin play, so as soon as it starts, I want to animate. And to animate it, we're going to use a timeline. And the timeline is going to be, what should we call it? We'll call it materialize. Okay. You can call it whatever you like, but I name it so it makes sense at least. So if you double click on a timeline, you open up the timeline so you can set up what it's going to be doing. And for this, I need to add a vector track, and this is going to store the values that I want to be the size of the mask. Okay, so I'm going to go mask size, like so. And if I hide the Z, because I'm only dealing with X and Y, I want to put this into a graph. So let's just do X first of all. So I want it to create a point there. So you hold down Shift and click to add a point. So I add 2 points there. And the first one I'm going to set the time to 0 and the value to 0. And the second one I'm going to set a time to 1 and the value to 300, or whatever the width is of your mesh. So let's have a look at actually the width of our mesh. So here I can see my mesh is 258 by 166, so it'll be 166 in the Y direction, like over there. Okay, so that's not too bad. And 258 in height, so 166. I can leave that at, what did I put that at? 300. I can leave that at 300. So I'm going to hide and lock the X one. I'm going to show the Y, and the Y is going to handle the other direction. Oh no, not Y, the Z, sorry. The Z? No, the Y. And the Y value, we're going to do again 2 marks here. The first mark will be 0, and the value 0. And the next key will be type 1, and a value of 300 again. Okay. And we can show both X and Y on this graph like so. I'm going to change the length of it to be 1, because my keys only go up to 1. And I'm going to click compile. Now we'll be coming back to this to fine tune animation, because this is not what I want it to be like, but just to show you that it is working as such. So mask size here is now appeared as a vector pin. We now need to feed that into our material. So to be able to change materials parameters in real time, in runtime, sorry, we need to make it a dynamic instance of the material. This at the moment isn't dynamic. This is just a static material code. Okay, so we need to make a dynamic instance of it. To do that, we right click and click create material instance. So now we've got this, we need to assign it to our meshes. So we're going to use this one rather than this one. So go into each of your meshes, and we're going to just put in, make sure we're using the instance version of this. Oh, I don't think I changed it on the other one, did I? Let's go back to there. There. Okay, so we've got those two there. What we're looking at now doing is adding the parameter to this instance at the moment. Okay, so at the moment it has no parameters. We need to start inserting some parameters. If you're just joining us, welcome. We are today trying to create the door effect used in Zombies Ate My Neighbours, and the door effect is such like so, where it materializes into the world, and that's what we're recreating at the moment. If you've missed the start of this, don't fret. The archive of this will be up for Patreons immediately after the stream. So if you want to watch it, you can just donate $1 and watch it all, or you can wait a couple of weeks and it'll be released publicly on YouTube. So this is what we're trying to make, and so far we've got our door material, and we made an instance of it, and we've got using the box mask 2D and explained what that does. So let's talk about this parameter. So we need to turn this into a parameter. So if I just right click and type in parameter, you'll see a load of options for parameters here, and I want to use a vector parameter. And here we're going to go mask size, and like we did before, we're using 50-50 in R and G. We can do 50 in R and 50 in the G as a default starting value, and put that into my bounds. So now I've got that as a parameter. What that means is if we apply it and go over to our instance, you'll see the mask size is now appearing as a parameter, meaning that we can change this to suit our needs. So to show you that, I can increase this, and you can see it changing the size of the parameter. So with that in mind, I can go into my exit door code here. I can get my dynamic instance and set up a vector parameter for it. So I'm going to go type in vector parameter, and you'll see set vector parameter on material static mesh and static mesh 1. So I've got two meshes. I need to do it on both. So click on the first one and click update. Plug in mask size into it, and the parameter name was mask size. So call it mask size, and do exactly the same thing again. Come out of here, vector parameter static mesh 1, and we're going to go mask size and plug mask size into there. Great. Click compile, and let's see how this looks in the actual game. So I'm just going to drag in the door so you can see it from the get-go. Push play, and you saw it happen there. If I just click these three, you see another one spawn. Okay, we've got it kind of there. It kind of fades in, not too bad. However, I want it to fade in from the top. I want it to fade in from the front, because if we look at our reference image, you can see the door starts at the front side of the door rather than the top of it, so it fades sort of like in the horizontal plane rather than the top plane. So we need to rotate our mask so it's going forwards rather than down. Hopefully that makes sense. So to do that, we are going to open up our material, not the instance, the actual material, and take a look at our box mask 2D. Now box mask 2D, this A is our world position where it starts measuring the box. So what we need to do is rotate this vector that it's using by 90 degrees so that we can actually see it from the front. So to do that, I'm going to get the world position coordinates, which is what it's using by default. I'm going then to rotate vector about axis, and I want the absolute world position to go into this position here. So drag that into there like so. The normalized rotation axis. Now whenever you see the word normalized, that just means it's going between 0 and 1. Okay, so the value will be either 0, 1, or anything in between. So what we're doing there is I'm just going to set up a vector, so 3 on the key, hold down and push left click and put that in like so. And the normalized vector means for the rotation, you just indicate which axis there is. So R, G, and B refers to axes, so X-axis, G-axis, B-axis, and how you want to rotate it. Now I want it to rotate so it's forwards this way, so I need to rotate in the Y-axis. So it's normalized, so I want to rotate it 90 degrees in that axis. So the axis I want to indicate is G, which is 1. So that would be indicating that I'm using just the Y-axis. And the rotation angle is going to be is also normalized. So here we're going to do a single constant, and that's going to be 0.25. Because it's normalized, 90 degrees is 0.25. And the pivot point, I believe we need to put in the active position. So drag active position into pivot point, like so. With that in mind, we can now, or with this done, sorry, I think we need to do something else, but let's just plug it into A and see if that's done it. Has that done it? Let's click apply. Let's have a look. So we have got something working, kind of, in a weird way. What's happened there? Rotation about axis. Why has it done that? That's a new one. So it's rotated it this way. Hang on, I've got some notes I made prior to this. Let me have a look, see if I can find them. Let's put that on my big screen so I can actually see what I did in my notes. So oh yes, that's what I've missed. Okay, I need to add. So what I've missed is when you rotate it, we also need to add it to the absolute world position as well. So let's add that to the position of the world and plug that into A. Click apply. Okay, so there we go. There you can see it. Okay, so now it's going on the front rather than on the top. Okay, so let's click save and let's see how that looks. So you can see it kind of working. Let's go spawn another one in. So it spawns it in, but notice it doesn't go to full width and height and all the rest of it. Okay, that's because we need to do a couple of things. And first of all, we need to offset it, because what it's doing is measuring from the active position. So when I said, where is it? Where we've got the pivot point being the active position, which we need it to be. We need it to rotate around the active position. We need to be also change it so that we can actually offset it above, because on our viewport, notice the root is at the bottom of the door. I need to be in the middle. So I need to offset this by the height of this box here. I can get the height of that box by looking at here. And I can see that doesn't help too much either. Let's just offset it manually and see what happens here. So to offset this, we need to take this value here from this add and add another value to it. So go add again into A, and the add here is going to be a vector. So I'm going to put in another constant 3 vector, put that into the add, and I want to raise it by a certain amount of value. So let's raise that by 500 in the B, which is the Z, so raise it up. Okay, and let's see how that is looking. So it should, on here, it should show sort of in the middle of this object. Well, at least on the door anyway, it's done that. Let's have a look, see what it does in game. We still need to change the size of it. Okay. So let's look at our size of it. Going to exit and into our timeline. And let's increase the value of. Well, actually, let's just test it first in our material. So if you want to change it from a ball to the actual material you're going to be using it on, you can actually do that. So all you do is you select the mesh you want to use. Oh, pardon me. I've got to go sort out something. Literally be right back in 2 seconds. I'm back. Sorry about that. I thought babies were crying. Where was I? Oh yeah. So so if you select the mesh in your content browser, then in here click on a little teapot icon. It will select the mesh you've got selected in your content browser as the preview mesh, which is really handy when you're doing stuff like this. So we can see here this thing. So why is that not working as intended? That should have risen it up a bit. Why not though? Not too sure. Well, let's work with what we've got for now. We can always come back to that. Yeah, so we can test what value we need to set it as. If I go to mask size here, so by default it starts at 50/50. So if I change these values until I get the whole thing in, R is not changing anything. G is. So I need to change. I know R does change it, but not as much. So I need to increase that value to go beyond 300 by looks of it. Looks as though it has to go to maybe 600. Okay, so in the X to 600 and to the Y 300. So back on my exit timeline, let's hide the X, do the X first. This one's going to be what did I say it was 600. So value 600, and in the Y 300 was fine, I think, wasn't it? Yeah. So let's test that out now. So whole door should now show, which it does. Good. So let's spawn another one in. Okay. So we've got some work going on there. That's good. But we haven't got it really flashy or showy or anything like that. So first thing we'll do is I'm gonna mess about my timeline here, so it is actually a bit cooler and a bit nicer to use and so forth. So it's very static. It just goes from 0 to 1. I don't want to do that. I want to make it a bit more lively. So because if we look at again our reference image, go back to my reference image. So notice the door sort of grows upwards first and then grows sideways. So we need to make it do that. So if I change my X to do something like that, hide that. Our X value, we want to not actually do anything. Sorry, do all the work first, and the Y to come in later. So we need to show Y. And with this one, my time here, I'm going to change that to 0.4. Okay, and it goes like so. Click compile, go back, push play, And it's going a bit fast, so I spawn another one in so I can actually see it a bit more detail. Yeah. So we're going, so here we're going up, and we want it to be basically full size by the time it starts growing out here. So let's change this then to 0.5 and that to 600 there, and click compile. Let's see how that looks. Still very fast. Let's maybe slow it down a bit. So I'm going to change my length here to 2 seconds. Let's make that 1. Just double the time slot. So 1, 0.8. That one's 2. And that one is also 2. Just so we can actually see what it's doing, we can slow it down. Okay. Collect all of these guys, see it again. Still not happy with that. So what can we do to this? Let's think about it. So I want it to go up fully before it starts growing. So this actually needs to be to 1. That's what I've done wrong there. Push play. That's a bit better. But what I want to do instead of it being 0 at the start, because now you can see a very faint line going up. That's because that first vigor is 0. So this, I don't want to be 0. I want it default here to be like 20 or something like that. Compile that. Push play. That's a bit better. Let's do that again. Spawn another one in. Yeah, cool. We like that. Okay. So that's one half of it. The other half is I want to add that glow effect to it. So again, let's take another look at our reference image. So it's got a little glow effect that goes around it as well. So we're going to also do exactly the same what we just done, but we're going to do it with a glow instead around it. So sort of offset it with a glow. So in my material here, we're going to do another box mask 2D. So I'm going to copy that out again like so. And what we're going to be doing here is, pardon me, creating another mask. Really? Oh, pardon me, I'm so tired. Now let's change it back to a ball so we can actually see what it's doing. It'll be here. And this thing's going to be doing an emissive on it, okay? So we're going to be emitting some light from this. So an emission is handled by the emissive color. That's why if you want something to light up. So from here, we're going to get a color we want to use. So I'm going to go 3 and click. Again, 3 and click. There we go. To get a color for the emission, I want it to be a bright sort of yellow orange sort of color, like so. And that's going to come from this box mask. So box mask 2D. I'm going to drag this out and multiply this by this color. Now you multiply it because this is going to return a simple white square on a black background. If you multiply white by a color, it will turn all white into that color. So that'll multiply that. But then also I want to multiply it by a certain value to increase its strength, because a value of 1 for the multiplier is quite weak. So multiply that by something like 10, for example, and that will really glow. I don't think we'll see anything yet because it hasn't masked yet, but we'll get there. Okay, so to mask it, we need to get the bounds. So bounds, I want to take the mask size, but also want to add a value to it so it sort of outlines it. So if I have another 3 vector, and let's change this to something like 50, 50, 50. These are going to be added like an offset onto my mask size here, so I can see an outline of the glow edges. So add glowing edges, we're going to do this. So we're going to add this parameter to that. We need to add it to the parameter because that's the thing that's going to animate it. So we add the offset to the parameter, and the parameter then will go into our bounds for this one here that we just added. Okay. With that done, we need to put in our B value, which is our active position. So it's the same as the other one is. It's going to get a bit messy, so double click to add some nodes in or space things out. I'm doing mine quite compact, but you can spread it out, of course. So that goes into B, and then we need A, and A is going to be exactly the same as this one because it's exactly the same position, it's just different offset. So I'm going to drag that into there like so as well. So now I've got two masks happening at the same time, and there you can see the emissive happening. Now it's put over the top. Oh god, because it's just emitting that colour. We need to make it so it's an outline rather than just the whole thing. So what I'm actually going to do is I'm going to take away this box mask from this one, and I want to use this one for its opacity mask. So if I drag that into the opacity mask like so, that'll make it a bit bigger because we've got that offset over here, and you should see it a little bit bigger. Yeah, so it looks a bit bigger. I need to now cut out basically here this box mask 2D. So if I take this away from our multiplier, now I can do it two ways, but I'm going to do it in this particular way. I'm going to do 1 minus, and 1 minus flips yellow and blacks around, so white and blacks around. So that white square that box 2D produces is now going to be black, and the black's going to be white, and that means I can now multiply this node. Let's just put this over here, multiply this again, multiply that by that, and plug that into the emissive color, and that's going to basically cut it out because multiplying by 0 gets you 0 and black is 0. So it's now going to cut out a square matching this box 2D out from here. So now we've got outer glow edges. Pretty nifty. Apply that. Click play. Oh, gotta wait for the shaders to compile. Let's just see what chat's going on. Hi everyone in chat. Thanks for coming by this evening. Let's just read a couple of questions I've got thrown at me. Can I make tutorials and do smoother animations like the animations in GTA 5? Those animations are mostly inverse kinematic animations. Very advanced animation systems. Obviously a lot of work. I'm not a big animator, so I could give it a shot, but I definitely want to show IK stuff. But I say if you want to do smooth animations, then you need to get a better animator to do that. Can I make a tutorial on making a teammate AI? Yep, we're working on that relatively soon, so keep an eye on that on Patreon if you're on there. If not, you'll see it in a couple of months' time on the YouTube channel. Hi everyone, thanks for joining us. Hopefully this is, yep. So back to what we're looking at here. So you can see the glowing edges working there. Let's go back to push play here. And there's our what's that, Rodrigo? I think I have the overlay over the image. Hang on, I can't see the stream, what you guys are seeing. Let's have a look, see what you guys are streaming. Oh, still got the media source. Oh yeah. Oh, sorry. I don't know what bit you missed out. Sorry guys. I totally forgot that was up. So let's go back. I'll go back to this. Sorry. Let's redo this. So our mask 2D. We've got a box mask 2D. This is the original one. Here's my second one, and this is going to be doing the glowing edges. So the glowing edges are handled. Actually, let's just delete this so I can show you all again. I don't know how far I got with you guys, so let's just remove all this stuff this stuff, and plug that in. So hopefully this is back to where you guys saw it. Sorry about that. To make sure it isn't overlaying again. Cool. Okay, so hopefully that's all groovy. It is live, so there will be problems. So let's do this again from scratch. Okay, so to recap, here is the square that we've masked previously. We want to make glowing edges around it. So to do glowing edges around it, we can do exactly the same thing we've done here, but we're going to add it and make it a bit bigger. So we need another box 2D. So I can just copy and paste that into there like so, and plug that into emissive color. Oh, not there, sorry. Multiply that first. And we're going to multiply it by a color that we want the emissive to be, the glowing edges to be anyway. So hold down 3, left click, and plug that in like so. So here I'm going to plug in a sort of a yellowy color, and I'll then multiply that again by the intensity that I want this to be. I find 10's quite nice for things that glow, so I'm going to plug that in like so. So with that set to 10, I can, if I put it into emissive color like so, you should see this now glow. Oh no, we've got to put bounds in first. Let's put the bounds in. You will see that glow. So let's go into here and look at our mask size. So this is the size of the box. To do an offset around it to make it bigger, we need to add something to this value. So let's add a vector to it, and a vector size of 50, 50, 50 will do us just fine. I'm going to add it to it. So add maths add, and that will now go to your bounds of your other box 2D. Apply, and will that show it now? Nope, not yet. We have to put it in the act position. So the B position, drag in, all this is exactly the same as before. So act position goes into B, and absolute world position, this all chain here, the last part of that will also go into A like so. And now you can see the emissive part appear. Now the emissive part is glowing the whole entire thing at the moment because we haven't told it to do an outline, we just told it to do a full solid shape. And it's smaller, it's the same size as the previous one because we've got our opacity mask still going through this one. So I want to use this one as the opacity mask instead. So drag this into your opacity mask as well. And you can see it's now bigger. And what I want to do for cutting out the middle part, so I've only got an outline, is I'll take this one and take it away from here. And multiple ways of doing this. The way I'm going to do it here is by flipping the colours around, so from black to white and white to black. You do it by using 1-. And so it just flips the colours around, so white becomes black, black becomes white. And if I multiply that now by this value, everything that was masked, we've now inversed it. So we're now going to mask out the mask, if that makes sense. You'll see it makes sense in a second. And that'll go into emissive colour. And it should, if I've done it correctly, yes. And you'll see it's masked out in the middle bit, the original part. So this has become a mask of this mask. It's masked out the emissive colour. Okay. So if I click apply now, and we push play. Oh, wait for shaders to compile. Click play, and you can see it sort of materialize into the world like so. There you go. So that's pretty much it. We're going to do a couple of things before we end tonight. The first thing we'll do is make it so that the exit level will only ever spawn the correct way round, so facing the correct camera, and also make it so it's always spawning onto the ground rather than in the air. you notice if I collect all the neighbours, 1, 2, and 3, it spawns in the air, which I don't want. I want it to be now down to the floor and facing the right way. So I think it's facing the right way. Yeah, it's facing, that one's facing the right way. This one isn't. So let's just nail it to the floor. So I'm going to do that in a construction script, and in here we're just going to do a line trace by channel. Start position is going to be its location, so get actor location, and the end location is going to be the actor's location plus a vector, and the vector is going to be a negative in the Z of, say, 500. Oh, negative 500. And so it's going to go directly downwards. And when it hits something, we're going to split the out hit, get our out hit location, and we're simply going to move our actor here to that location. So from here, set actor location, like so. Click compile. So now what that means is when I drag out another exit, it's going to snap it to the floor, and you notice I can't lift it up. It won't lift it. It will knock it down, but it may lift it up. So it'll always snap it to the floor whenever it spawns. So let's test that theory out with the collection of the neighbours. There you go, spawns on the floor. So let's work on that actual look of the animation that's going on there. So let's fine tune our graph we've got going on here. So I'm going to make it so it's less rigid and a bit more fun and bouncy. Okay, so if I right click on, say, let's right click on this one and go to auto, you'll see you can change these handles here, and it won't do it because I need to make this one auto as well. There we go. So now you get this curve, and we can manipulate this curve to do things like this, and it makes it sort of bounce as well. So I can really mess about with the values I've got here. I mean, it's a graph, so this is what the power of graphs allow you to do. So if I do this, for example, you'll notice that it animates a little bit differently. It's not lagging. Let's get to 3 so you can see it. So it sort of goes up really fast and then slows everything down. So it's called an acceleration curve. It's like that. Okay, so like your car accelerates fast and takes a while to speed up even further. So that's the acceleration curve. The inverse of that is that it starts off slow, then gets faster. Yeah. Like so. So let's have a look at how they've done theirs in the original game. Let's try and mimic it as best we can. So obviously you've got the, yeah, we got it pretty spot on. I don't think it's not too far off actually. It's quite linear and constant. So I guess it's just down to us to make it as fun as we want it to make it. So yeah, let's just make it a bit of fun. Let me have a look and have a see what we've got going on here. Okay, so just checking chat. So let's make all these curvy as well. So let's go auto there, and we can play about with these values like so as well. And if you want, you can put in other keys here. Don't have to have just 2. You can have multiple. I could put one here if I wanted to, and do this sort of weird thing. Let's see how that looks. So it does that sort of woo woo woo. Like it's unsure they want to materialise. Yeah, I don't like that, but we'll let's get rid of that. I don't like that. Okay, so we got that. Let's put that down a little bit there. Let's put this up like so. this like so. Let's give this an acceleration curve as well. I'll give this acceleration as well. Like that. And just move handles. So that looks. Yeah, that's not bad. We'll have that. Cool. And then we have the spawning and materialization of our doors. So the last thing it does in our reference image is you notice that the door actually opens. So it goes there and then it opens up for you. So we need to do that as well. So let's have a crack at doing that. Let's go into our exit door. Go into my event graph. And if you want to know how to open doors and animate the doors opening, a lot of those can be seen in my door videos that you've seen on my channel. By all means, check them out. But we're going to do one here as well. So once this timeline is finished, it will come down this path here. And on this path here, I want it to animate that other mesh, the inside mesh, the door mesh, to swing open. So on here, I can do two things. I can either rig it and animate the rig, or I can just animate it in code. I'm just going to animate it in code. So let's add a scene component. And a scene component is going to attach itself, detach itself first of all. This can be a hinge, so let's place it where you want the hinge to be. So I'm going to put it on that side of the door. And our static mesh 1, the actual door itself, I'm going to attach to my scene. Let me just change the name of my scene to hinge. And because the mesh is attached to the hinge, if I was to rotate the hinge, it'll rotate the door. Yeah. My swanky door is a breaking in the thing, but never mind. It'll do. Okay, so we've got that happening there. So we're going to animate this happening. So here I'm changing the Z value of the hinge. So let's just now go into our event graph. I'm going to do another timeline for after the materializer is finished. So let's just drag out another timeline onto that. Whatever, I could spell it right. Door opening. I'm going to play the door opening. So when we're updating, we need to put in a track, and because it's only a rotation, I could do a vector, or I could do a float. Either one's fine. I'm just going to do a vector, and I'm going to call it rotation. And the rotation of the vector is all in the Z, as we discovered. And in the Z, I want to rotate it. Let's just look at it again. I'll rotate it negatively to minus 50. Minus 50 would do. Even minus 40. Let's do minus 40. So let's put that back to 0. So one key there at 0, 0. Another key at we'll do 1, and then minus 50. And if I click these little buttons here, you can see it in all its glory. Because the door opening, I tend to like to make these curvy, as it's more realistic to how doors actually open and shut. So let's do that. Let's change this length to 1 and click compile. Go back to your event graph, and we can see that rotation's now there. And I'm going to drag my hinge out, my component list, and in the hinge there, I'm going to set rotation, and I can set relative rotation, drag that into update, and rotation I'm going to plug into new rotation. Okay, and let's see how that looks. Nope, it didn't work. Let's have a look. No, it didn't work at all, did it? So let's have a look what's happened there. So I think it's happened from rotation from X vector. It's breaking it. So rather than make it a vector, let's make it a float then. Let's change that to a float. Well, in fact, we can just use that, what we've got there, and turn it into a float. Let's split this, and then split this. New rotation into Z. Compile, and check that out. There you go. It works on that one. So let's just check it in the actual game one. There you go. Cool. So once we've got that happening there, we could actually do it all in reverse as well after we overlap it. So rather than print the string, let's overlap it and do it all in reverse. So on overlap, we're going to close the door. So reverse from end. And once that's finished, we are then going to do the other one. So here I'm going to go a sequence. Ooh. And then, so close the door first, and then once it's finished, reverse from end as well. And let's see how that looks. It's a quick dirty way of doing it, but let's see if that would suffice. Oh, I walked right through it straight away. You see it's animating itself there. Right. Ignore the error, it's just AI error. So let's try not to walk through it straight away. Yeah. Okay. So we'll come back to this one and fix this, make this better, because I'm not happy with this. We need to, because we need to determine that it's finished. In fact, no, we could do it now. Let's just delete that. And delete that. I think we could just copy and paste this. Copy, paste that down here. But I'm going to do it in reverse. So this bit's going to happen first. Like so. And then this one is going to happen after they're finished. So it makes separate timelines. So let's just have a look at naming these. And call this one closed door. And disappear. Like so. Oh, I didn't collect it there. It goes there. Okay. We've got that happening. I could ideally check to make sure that the door is open. So when it's just finished, let's create a new variable and go door open. And go editable, not editable, sorry, leave it as Boolean. Compile, drag it out, set into finish of the opening and tick the box. And then when we overlap it, I want to check that it's actually open. So I'm going to go get, I'm putting the branch here. Doesn't matter really where you put it, before or after the cast. It's slightly more optimized to put it before, but never mind. Doesn't matter too much. So only we'll do this stuff if it's been opened. If it's already opened up. So let's collect all our neighbours. There's an exit. It's open for us. I'll walk through it. Oh. I've got to reverse it, haven't I? Not play. So rather than play, reverse from end. There we go. Reverse from end. Compile. Do that again. Collect 1, 2, and 3. It spawns, opens, closes, despawns. Sweet. And once it's done that, we can remove it. So from there, the last one, unfinished, we can go destroy actor. So 1, 2, 3. It spawns, teleports in, opens, walk through it, closes, teleports out. and it's destroyed. Perfect. That's exactly what we want. So that'll do for tonight. There are other things I would like to do to the door eventually, because I want to update it obviously for modern day sort of standards. So I want to eventually put on some particle effects, sort of do like a Bill and Ted moment where you have like electricity sparking out the ground and things like that. So yeah, so we'll get back to it at some point down the road, but that's what we add. So thanks very much for watching. Thanks for joining us tonight. This was Making a Game Live and making progress towards our Zombies Ate My Neighbours game remake. Next week we are doing a case study. So join us next week as I play a game and go through it. The game will be announced probably Monday. We'll go through and talk about what game. I'm in between two games. So yeah, we'll go through that Monday. If you want to see the live archive of this stream right now, you can head over to patreon.com/RyanLaley and support me for just $1, and you get access to this stream relatively soon after we finish here tonight. Or you can wait till it's publicly available in 2 weeks' time. So thanks very much for joining us again tonight, and I'll see you next weekend for our next live stream. Don't forget, we've got more videos coming out all week. Another video coming out tomorrow and on Monday, and another one on Thursday. So plenty more content coming. Head over to Patreon if you want to see videos 2 months ahead of time. So there's loads of stuff on there. There's like 13 videos up there that are not out yet. So yeah, thanks very much for watching, and I'll see you guys next week for our case study. Cheers and good night.